This video is over topic 3-4 where we are revisiting functions. The bell work asks us which of the following relations is a function. Remember, for something to be a function, it has to be a nice, healthy, working relationship where your x's don't repeat. And in this question, we are looking for which of these are a function, so if your x's repeat, cross it out. In the first one, we have x's of 2, 2, and 2. That one is not a function because your x's repeat. And the second, 2, 1, 2. Not a function because the x of 2 repeats. 2, 1, 3. That one is good. 2, 4, 3. That one is good. So we are looking for an answer for 3 and 4, which would be answer choice C. Today we are looking at how you can evaluate functions on a calculator. You are going to press the y equals button, input the rule into y1 using the x, t, theta, or n button for x, and then press second graph to see the table of values. So in problem 1, they want us to use the f of x function, that's what that f means, and find where x equals -3. So I'm going to plug this into y equals, and then look at this on my table. So when I go to my graph, y equals is up at the very top left. I'm circling it with the cursor. So when I click y equals, if there's anything in there, you can just click clear to get rid of it. The x button that you are going to use, mine just shows an x, which is a little bit easier. So you want to find the equivalent of this on your calculator. It is under the mode button, or you could say it is at a right diagonal from the second button. I don't really care how you say it, but that's where it will be. So the f of x function is x squared plus 4x. So I am typing the function into y1, or y equals, in y1 and y equals. Then you are going to hit second graph to go to the table. Again, we are looking for where x equals -3, so you can use these cursors, the top and bottom, to scroll up and down on the x's. And then here's where x equals -3. Remember, the x goes on the inside. We are looking for the output. In this case, the output is the same. The output is also -3. If you forget how to do this in the table, you can plug in by hand. X squared plus 4 times x, and you should still get -3. Problem 2, I'm going to plug the g of x function in this time, so 5 minus 3x. So I go back to y equals 5 minus 3x. And remember, we are not using the alpha x button, we are using this x button. I click table, and I scroll up to see when x equals -5, y equals 20. Problem 3 asks us to find two separate pieces. So first I need to plug this back into y equals. So x squared plus 4x. And click table. And we are looking for f of 1. So I scroll down. When x is 1, y is 5. So I replace f of 1 with 5. And then I need to find g of 3. For g, we are using the g of x function, 5 minus 3x. So I come and replace that again, 5 minus 3x. Second table, and I am looking for g of 3. When x is 3, y is -4. And then I simply add these. 5 plus -4 is 1. Now, a trick for you, if you have two functions in your y equals, if you go back to y equals, you can see there's lots of different options, y1, y2, y3, y4, y5, and so on. So what you can do is plug in f of x in y1 and g of x in y2. When you go to the table, it will tell you y1, which is your first function, and y2, which is your second function. So for example 4, They want us to find f of negative 2. So this is my first function. So I'm going to go to y1 when x is negative 2. So when x is negative 2, y1 is negative 4. Right now we're not looking at y2. We only want y1. So y1 is negative 4. Now for the second part, now we want the second function because g of x was what I put in second. So g of x, I'm going to go to 4 first on the x. And then g is the second function. So I go look over here in the y2 column. And for g of 4, it is negative 7. And then negative 4 minus negative 7 is a positive 3. You can double check that on your calculator. So again, if you plug in y1 and y2, first function, second function, and then just remember to be good about switching to the other side of the calculator, that will help you save a lot of time. If that confuses you, you can type all of them in separately and plug it in each time. So here, we need to replace g of negative 2. I've already plugged this in, so I can go... So I can go to negative 2. Remember, my g function is the second one, so g of negative 2 is 11. And right now I'm not doing anything with that 2 that's on the outside. What they want me to do is some operations once I plug in my numbers. So the first thing I'm going to do is figure out those numbers. I've already found g of negative 2. Now I'm going to find f of 2. So I scroll to where x is 2. My f function is the first function. So f of 2 would be 12. And then I can plug all of this into my calculator exactly like I see it. 2 times 11 minus 3 times 12. I'm just going to double check. Yeah. So I plugged it in exactly like I see it without, instead of the bracket, I just do a second parentheses. And I get negative 50. So again, you can use y1 and y2 if you want to save some time because that helps out a lot. If not, just make sure that you are changing your y equals values like we did on problem 3 every time before you go back and look at the table. This brain strain is asking us if f of 8 is negative 3 and f of negative 3 is 8, what is if y equals f of x, then what is the value of y when x equals negative 3? So we're going to plug negative 3 in, and then we just look at our information up here. F of negative 3 is 8. So we didn't even use that piece. On the back, we are reviewing some of the discrete graphs that we looked at a week ago. So they ask us first to list the points. So I'm going to start top to bottom. That is the point 0, 7. Oops, hold on. Then this one is 9, 1, 2, 3, 4, 5, 9, 5. This one is negative 3, 4. This is 4, 2. This is 2, 0. That one down there is negative 2, negative 5. And then my last point left over here would be at 4, negative 6. From our saying, Dr. XY wears his ID in the office, I can refresh my memory. That domain is all of my x values. So my x values are 0, 9, negative 3, 4, 2, negative 2, and I've already written 4. Remember, we do not repeat. My range, Dr. XY, is all of my Y values. So 7, 5, 4, 2, 0, -5, and -6. And these are all coming from the second number in my points. Question 9 asks us if this is a function. The answer is no. Problem 10 asks why. Because x of 4, when x is 4, it repeats. And remember, like we talked about on the bell work, if it repeats, then it is not a function. Problem 11 asks us for f of 2. So this is saying x is 2. What is y? So when x is 2, we can come up to our point. When x is 2, y is 0. 12 asks us for x when x is -3. What is y? So when x is -3, y is 4. Problems 13 and 14 look different. This time they're telling us f of x equals 7 and asking us what x equals. So this time we don't know x, but we need to find y. So, I'm sorry. We don't need to find y. We don't know x. We need to find x. They told us here, remember we talked about on 3.3, f of x is the same thing as y. These two are the same. So instead of f of x, we could say y equals 7, and then we come up to our points. When y is 7, x is 0. And then on 14x, we don't know y. They're telling us is -6. So we come up when y is -6, x is 4. Problem 15 asks us to find the domain and range. This one has one bubble, so we will have one inequality. I'm going to frame my bubble using arrows coming from my bubble so I can see what's happening. This is the point, this is the point 8, -2. And we remember that domain is our x, so x and 8 will go together. And then y is our range, so y and -2 will go together. Now we just have to figure out what direction my inequalities go. My x arrow is the one that goes left to right, or right. It's either going to the right or going to the left. This one is pointing to the left, excuse me, and left indicates x is getting smaller or less than -8. So it starts at -8 and is moving towards the left, which would be towards the negatives. My y is the one that's either going up or down. If my y's are going up, then my y's are getting greater than -2. So if you frame from the bubble, your line has to be in between your frame. Your frame arrows will tell you where it's going.